This is an experiment to look at the method of making a soluble salt. It is sometimes called the insoluble base method. To speed things up, we are going to use sulfuric acid, which is heated. We're using approximately 25 cm cubed of the sulfuric acid. This is dilute sulfuric acid. It doesn't have to be accurate because we're aiming only to make some crystals of copper sulfate, and we are not doing a quantitative experiment. We will warm the sulfuric acid first of all. So we have got hot acid in the 100 centimeter cube beaker. We're going to add to this copper 2 oxide, which is a black solid. It is insoluble in water, but it does react with the sulfuric acid to form copper sulfate and water. The copper sulfate is a blue solid which is soluble in water. It is a soluble salt. So this is a method of making a soluble salt by using a heated acid and an insoluble base, copper 2 oxide. Once the acid has warmed a little, we will add some of the copper oxide to the acid. The copper oxide will neutralize the acid and make copper sulfate and water. But while it is relatively cold, this reaction will be slow. And so the black solid appears not to be reacting with the acid, or not particularly quickly. But quickly we'll see that it becomes a blue colour to the solution, and the black solid, which is at the bottom, with a little bit of stirring, quickly disappears. Now at this point we have the sulfuric acid at a good temperature for the reaction, so the Bunsen can be turned down. And more copper oxide can be added. So the process of adding the copper oxide is to neutralize the sulfuric acid and to make the copper sulfate. So at this point, of course, the reaction is almost instantaneous at this temperature. So we will just turn the heating down a little bit more so that it's under a little bit more control. A little better. So as we add the copper oxide to the hot acid, you will see that it of course will react. As it reacts, it disappears. It disappears because it reacts with the sulfuric acid. So we know at this point that we definitely have an excess of sulfuric acid. Each time we add the black copper oxide, it reacts to form the blue copper sulfate. Our ultimate aim in doing this is, of course, to completely neutralize the sulfuric acid. And we will know this when the copper oxide no longer reacts. And because it's insoluble in water, we will see it left in the bottom of the beaker. Okay, so at this stage it is still disappearing. So we continue to add. Continue to add and allow it to disappear. Our aim, of course, is to add a very small quantity above the neutralization point. We'll allow that one to react. We're then going to filter. We're going to use fluted filter paper. If we were to set this paper up in the traditional way of just folding twice and opening up with 3 layers and 1 layer, it is not as efficient as if we had only 1 layer. So to achieve this, we make fluted filter paper. To make fluted filter paper, you fold once, twice, 3 times, and a 4th time. On the 4th fold, you make sure that the folds can move in either direction by turning it back on itself and refolding it in the opposite direction. Once we have done that, we can open it up and start to fold backwards and forwards from a particular point. We just pinch and we fold backwards and forwards. And you get to a certain point and then open up a little and continue until eventually you're all the way around the filter paper, so that you have the fluted filter paper like so. Okay, so what's happening here? Well, it looks as if there's a little bit of the copper oxide left, but no, on stirring it disappears. So we still need a little bit more of the copper oxide, so let's add in there. But we're probably heading towards the end. You can see that the black solid is not immediately disappearing despite the heating. And so this may be the point at which we have an excess of copper oxide. So we know that all the sulfuric acid, on the assumption that this doesn't disappear, we know that all of the sulfuric acid will be neutralized because we have an excess of copper oxide. And we now need to get rid of that excess of copper oxide if we want to get pure crystals of copper sulfate. So we are going to filter. The black copper oxide is not soluble in water, and so it remains, and so it will be the residue when we do this filtration. Okay, it does look as if no more of the copper oxide seems to be dissolving. So we will pour. Very carefully so that there is no reason for us to put the excess copper oxide through the filtration because we don't want that, and so we're hoping to get a dark blue solution which has no copper oxide present. Now, as we were saying earlier on, we only need to get some copper sulfate crystals. So at this stage, we don't need to wait for this filtration to complete. We can simply work with this quantity of the copper sulfate solution. So we are assuming that this solution has no sulfuric acid in it. We're also hoping it has no copper oxide and that none of the copper oxide has gone through the filtration apparatus. We're hoping that all the copper oxide is either in the beaker or has been caught by the filter paper. Okay, once you think you have sufficient of the blue solution, we need to effectively get rid of the water to leave us with the copper sulfate crystals. So we'll remove this at this stage, and we will place this back onto the Bunsen. So we just raise the temperature slightly again, and we start to heat. Now at this stage we would want to heat to a point where crystallization is likely to occur. So as we start to heat, if we had a little longer, we could heat this more slowly and allow this to evaporate off. But you'll find that some copper sulfate crystals will start to form around the outside. And in fact, some anhydrous copper sulfate, white anhydrous copper sulfate, will also form because, of course, at this temperature, the water crystallization will also be driven off. So we will just get that to a point where it is starting to boil, and then we'll try and control the boiling and gently evaporate off about half the water. We might use the glass rod to see if crystallization is about to happen by dipping the rod into the solution and looking to see if there's any formation of crystals. You can decide whether it is the right moment to transfer. What are we going to transfer into? Anything really where the crystals will form. A petri dish or a petri dish lid is exceptionally useful here because the depth of the liquid will be very shallow, and so evaporation can occur very readily. We'll pour into that petri dish once we feel that we have sufficient water has been driven off from this solution. As you can see around the edges, there's some signs of both blue, but also definitely some white or near white anhydrous copper sulfate. So we've got it boiling now, so I will again turn the Bunsen down to a very low heat and just allow that to boil for a few minutes. So at this point we will transfer across to the petri dish.